So after discussing various methods to prepare haloalkanes using alcohol, alkane, alkene and whatnot, we are also going to discuss some other methods for preparing haloalkanes, that is from silver salts of carboxylic acid and also from halide exchange method. Now these two are very easy, you don't have to worry about anything in these reactions or in these preparation methods. Nothing to worry about, these are pretty easy as compared to the other ones, so just relax and enjoy this video for that matter. Okay, so first of all, let's talk about this preparation of haloalkanes using silver salts of carboxylic acid, and I'll try to make it as easy and as simple as possible for you guys, so you don't have to worry about anything. So first let's take the silver salt of carboxylic acid. So I have taken a silver salt of carboxylic acid here. So let me write that down. Silver salt of carboxylic acid. And what I'm going to do is I'm going to react it with dibromine. This is my bromine, and the product that I'll be getting is obviously the first product that I will get is bromoalkane, my haloalkane that I wanted to prepare. So that is prepared already. Along with that, I'll also get a silver bromide and also carbon dioxide as one of the products. So I got my bromoalkane, I got my silver bromide, and I've also got my carbon dioxide. Bromoalkane is the haloalkane that I wanted to prepare, and you can see that I've prepared it very easily using silver salts of carboxylic acid as well as a dibromine. Now I'll also tell you how this, I'll also give you an idea how this reaction basically happened. So you had two bromine atoms present here, so that is how you got your haloalkane. So one of the bromine atoms will go and attach with your carbon chain, okay, then so that happens, and another one will go and attach to the silver, and also your carbon dioxide will form and will also form as a product in the react in the product side. So that is how your haloalkane, your sodium, your silver bromide as well as your carbon dioxide is formed from this reaction. Now I'll give you the name of this reaction. This reaction has a fancy name, but don't need to worry about anything, just learn the spelling, learn to spell this. It is known as borodine. Trust me, my spellings are as bad as yours. Okay, I don't mean to offend anyone. Maybe your spellings are much better, but let me say it is a very hard spelling. Hunsdaker. I always get confused in this. Hunsdaker reaction. This is known as your Borodine Hunsdaker reaction. So you had your silver salt, you had your dibromine to get your haloalkane, your silver bromide, and your carbon dioxide. This preparation method was from silver salts, and this reaction, this particular reaction, is known as your Borodine Hunsdaker reaction. And I'll also give you a precaution here that this reaction is not advisable if you're gonna use chlorine. It is not advisable for preparing haloalkanes if you're gonna use chlorine as a reagent here. You never use chlorine. It is not advisable at all for preparing haloalkanes using chlorine. Now let's put that aside and let's look at some other product. Let's look at if you want to prepare iodoalkane. If you want to prepare iodoalkane, obviously you might be saying just replace your dibromine in the above reaction. Just replace your dibromine and put in your iodine. As simple as that. So let's do that. Let's say I have my silver salt and I'm going to react it with iodine, but the answer or the product that I'll be getting is an ester. It is not an iodoalkane. That is the problem here. So you do not get an iodoalkane. Iodoalkane cannot be formed from silver salts of carboxylic acid. This is not possible. Iodoalkane, iodoalkane cannot be formed from silver salts of carboxylic acid. This is the thing that you have to keep in mind when it comes to preparation of haloalkane. So basically we are trying to tell you that this reaction is basically helpful for preparation of bromoalkane, because iodoalkane cannot be formed from this reaction at all. An ester will be formed, and I'll tell you about this reaction. This particular reaction where you get an ester, another fancy name for this reaction is that this reaction is called as Birnbaum-Simonini reaction. This particular reaction is called as Birnbaum-Simonini reaction, and this was the reaction in which we used our silver salt of carboxylic acid, and we used it for preparing an ester, but iodoalkane is not formed at all from this reaction, and ester is formed in the place of iodoalkane. So this reaction is not at all favorable for the preparation of haloalkane. Moving on, another cool method for preparing haloalkane, and this method is known as halide exchange method. So HALIDE, halide exchange method. Halide exchange method. Now halide exchange method is fairly easy. It is very simple method. This method is also called as your Finkelstein reaction. This reaction through which halogen at haloalkane is prepared is also called as your Finkelstein reaction. And basically what we are doing is that we are taking a bromoalkane and we are going to react it with, for you can take any alkane you like, any haloalkane you like, and you're going to react it with sodium iodide, and this reaction occurs in the presence of acetone. So this reaction has to occur in the presence of acetone as a solvent. Here acetone is being taken as a solvent, and the product that I'll be getting is generally your C2H5I, that is your iodoalkane. Along with that I'll also get a sodium bromide. So you see what has happened here. You see that there is an exchange which has occurred. Just compare the reactant and the product side. You can see that there is a difference between the product and the reactant. There's a minor difference. You can see that there is an exchange that has occurred. So if you see here, this is your bromoalkane, because bromine is attached to this, and bromine is attached to the alkyl group, and here you can see that iodine is attached to the alkyl group. So this is your iodoalkane, and basically what is happening here is that your bromine is exchanged. So there is an exchange that has occurred between sodium iodide and bromoalkane. What exchange? Exchange of halogen atoms. So from alkyl group your bromine will go out and will attach to sodium, and from sodium iodide your iodine will go out and attach to bromine. So that is an exchange. They both have exchanged their halogen atoms. Sodium has exchanged its iodine, and bromoalkane has exchanged its bromine atom. So there is an exchange of halogen atom, there is an exchange of halides that is occurring. So this method is called as halide exchange method. It is very easy to understand, very simple, extremely simple by the way. You don't have to worry about anything in these reaction methods, and I'll also tell you the name of this particular reaction that has occurred here. This reaction is called as Finkelstein reaction. Another fancy name, just write that down if you want to. It is known as Finkelstein reaction. Finkelstein reaction. Now another thing that you have to know is that why are we using acetone as a solvent? What is the reason for using acetone as a solvent? Well, the answer is simple. We are using acetone as a solvent because it is because of acetone reaction proceeds in a reversible manner, if acetone is not used. So this reaction will occur, or this reaction will proceed in a reversible manner if acetone isn't used, and we do not want it to proceed in a reversible manner, because then we'll not get our product, we'll not be able to get iodoalkane. So we do not want it, we never want it to proceed in reversible manner. We want it to proceed in an irreversible manner. We want it to proceed irreversibly so that we can get a product as your haloalkane, because that is what we are aiming for. We are preparing haloalkane, so we want our haloalkane as a product. We do not want it to go back to the reactant. That is why we have to make it irreversible, and we use acetone as a solvent to make it irreversible. And I'll also tell you why we are using acetone as a solvent to make it irreversible. The answer is simple. When you use acetone, so here if acetone is used, first of all look at sodium bromide. Sodium bromide is insoluble. It is insoluble in acetone. So if you're using acetone, sodium bromide will be insoluble in acetone. So what happens, since it is insoluble, it precipitates out of this complete reaction. So there won't be any reaction with of sodium bromide and iodoalkane to form bromoalkane and sodium iodide once more. It will not be reversible if your acetone is used, because sodium bromide will precipitate out since it is insoluble in acetone. It is never soluble in acetone, so it precipitates out and your final product will be your iodoalkane that is formed. So no need to worry about that stuff. If you are using acetone, this reaction will become a irreversible reaction. It will become an irreversible reaction if acetone is utilized as a solvent, if this reaction is occurring in the presence of acetone. That was about the other methods for preparing haloalkanes. Thanks for watching, and as always, take it easy, and I'll see you in the next class.